I'm going to take you through my solution process for trial number 5. So what I have here at the top is what you're supposed to produce on separate paper, not in Pivot Interactives. So let's go through these. I've done some of this already. Number 1, describe the data collection process used to make the motion model. All right, well, here's mine. Okay, so you're welcome to read it, but there's not a whole lot of, well, there's enough detail there. But it's short and sweet. Okay, so you can just review that. Number 2, make a meaningful sketch of the race scenario. All right, so here is my meaningful sketch of my trial 5 model. In mine, Blue started out at the rear, so I put it at the 0 position. Red from the video I got was 8 centimeters, and white from the video I got was 24.5 centimeters ahead of Blue. Okay, now these are my velocities that I got from the video analysis. Blue was 25.7 centimeters per second. Red was 28.2 centimeters per second, so going faster. And white was 23.3 centimeters per second, so going slower. So I can tell already that Blue, there's no way Blue's going to win, right? Because it's behind Red and it's going slower than Red. I'll just keep that in mind when it might save me a little time when I do the actual solution. Also, on my meaningful sketch, I put the location of the finish line just because that's critical to actually come up with an answer here. So, and then from the video, I saw that it was 93.5 centimeters away from Blue. All right, so there's my meaningful sketch. Everything I need to make my motion model is here. So here's the motion model. That's the next thing. Publish your motion model. Okay, when I say publish, I mean I just want units. Okay, so let me just add real quick here. What's the format for our motion model? The template, rather, okay, x final equals the velocity times time plus the object's initial position. And what you're going to do is replace the v with a quantity and x with a quantity, x initial. And that's what I've done here. So I look at my meaningful sketch, and for the red ball, I just bring its velocity down here, and I put it in front of the t. I include units, and I put parentheses around it, because t is a variable, and these letters are not variables. They're there for units. And then I add its initial position is 8. White, I note that its velocity is 23.3. I bring that down here, put it in parentheses. I include units, and then where is it at the beginning? 24.5 centimeters. Blue, do the same thing. I bring its velocity down here, include units, put it in parentheses, times t. And then, since it's at the origin, you could write plus 0 centimeters here. But if we don't see anything written here, then that's what we infer. That's what we pretty much know, is that, oh, this must be at the origin because there's no position written. That's number 3. Number 4, make a meaningful sketch. This one's a little tricky because these differences in speeds are pretty small. So this is a little bit of an exaggeration, perhaps. So this is actually fairly challenging to do when everything is kind of pretty close together in speed. So I put the blue starts at the origin and goes at a certain rate, okay, 25.7. Then white starts out ahead. It's the furthest ahead, and it's going slower. So you notice I tried to make its line less steep than Blue, for sure. But again, it's just a sketch. It's hard, exactly how much more shallow should it be. It's just kind of a guess. And red started out ahead of Blue and behind white, and it was going faster. It's pretty subtle. Turn your head to the side. And I tried to make it so that red was a little bit steeper than Blue. But these numbers are pretty close, so kind of hard to do. So here's my guess of who's going to win of the order. And until we actually solve our problem with the equations, it's kind of a guess. But I think red is going to win, clearly. And then to me, it's going to be a pretty close finish for second place. And I think Blue is just going to squeeze out red. Blue is going to cross the finish line. Did I say red? I meant white. Okay, so in this case, it's kind of hard to make a prediction based on this. But anyway, this is what it is. This is what I'm looking for. All right, now here comes the solution. And I haven't started it yet. So, first thing I would need to do is I need to predict the winner. And so what I'm going to do is I'm going to take my motion model and I'm going to solve for the time that reminds, okay, I've got my calculator here. I'm going to solve for the time for white and red to finish the race, because I know there's no way blue's going to win. I don't think white's going to win either. I think red is going to win, but I don't know that for sure. Okay, why don't I think blue is going to win? Well, because here you go. Think about it. Blue starts behind red and it's going slower. So there's no way blue is going to win. Red will clearly cross the finish line before blue. What I don't know is who's going to cross first, red or white. White certainly starts out pretty far ahead, but it's going quite a bit slower. I don't know. That's what I got to solve. So I don't need to worry about blue because I know it's going to come in behind red. But I don't know, is red going to come in first or is white going to come in first? I actually think white is going to come in last place, but that's a guess. All right, so let's figure it out. So here we go. So the finish line is, I meant to have that already written down here. Let's see, finish line 93.5 centimeters. Okay, so basically what I'm going to do is, so we'll just write that down here, 93.5 is what I'm going to do is I'm going to solve for the time when red reaches 93.5. So here we go for red. Okay, so I'm going to say the finish line is at 93.5 centimeters, and so that I'm just substituting in for red's position that, and then I'm going to bring all this down here. So bear with me while I copy that down. Now I'm going to include the units in this line, but we're going to quickly drop them. Okay, next thing I'm going to do is drop the units to make the math. See, the units, I love units, but they can make the math look harder than it really is. So now this is going to be 93.5 equals 28.2 t. Going to need a calculator. These are messy numbers. Plus 8. All right, so basically I just need to solve for t. So I'm going to get rid of everything on this side that isn't t. First thing I'm going to do is I'm going to get rid of the 8 by subtracting 8 from both sides. All right, so what's 93.5 minus 8? Do I need a calculator? 80. Oh my goodness, 85.5, I think. I'm trying to make this fairly quick so you don't have to, but I think 85.5. Okay, and then this one's easy. That goes away. And now it's 28.2 t. Well, I definitely need a calculator for this because now I need to divide both sides by 28.2. Okay, that becomes 1, right? 28.2 divided by 28.2. Here's my calculator. Whoa. All right, so 85.5 divided by 28.2 equals 3.03 seconds. So the time for red to cross the finish line is 3.03 seconds. I'm going to go ahead and do the calculation for white. I'm going to pause the video, and then we're going to see who wins. Okay, so I've just did the calculation for the white ball, did the same exact thing I did with the red ball, and based on my motion model, is the white ball will cross the finish line at 2.96 seconds. So actually, it wins. So my prediction for my graph is way off. Okay, so that was just kind of a guess. This is not a guess. This is actually using our motion models to predict the future, right? So now I'm predicting white's going to win, but it's going to be very, very close, right? That's less than half a second. Okay, white, congratulations, you're the winner. All right, now the next thing is now that makes red and blue are the loser balls. And now my next task is to figure out how far are they behind when white crosses. Notice, just go back up here to our meaningful sketch. I'm not being asked what's their position when white crosses the finish line. I'm being asked is how far behind the finish line. So what we're going to do is we're going to put in white's winning time into these two position equations, and that'll tell us where they are on our frame of reference. And then we'll just subtract that from the finish line, and that'll give us the distance behind the finish line. All right, so let's get that going down here. So so basically this is now, whatever this is how far behind are red and blue. Okay, step number 1 is figure out where they are on our frame of reference. Okay, so we're going to put in the winning time, 2.96, in, let's go ahead and do reds. So we're going to go ahead and just plug in into red's position equation the winning time. So red is 28.2 and 8. Let's remember that. Okay, so basically the position of red at the finish is going to be 28.2 centimeters per second. I'm going to put in the winning time. Let me pause this. Okay, I had a little bit of an interruption there. So I'm trying to regroup here. So basically, I think what I was doing before I paused the video was we had to figure out where are R and B, red ball and blue ball, when white crosses the finish line. Okay, so what I'm going to do is I'm going to go do red's position equation and I'm going to plug in the winning time of 2.96. So there's 28.2 and 8, right? So 28.2 times the time, that's the winning time here. So that's going to be 2.96 seconds. And then it started at 8 centimeters. And let's see what I get. And this is going to be in centimeters. So that's 28.2 times 2.96, and then I add 8 to that, and I'm going to get a position of 91.5 centimeters. So this is where the red ball is when white wins. Oh, sorry, red. Okay, now the answer though is like, the question really is how far is R from the finish line, the red ball? So where's the finish line? The finish line, go at 93.5 centimeters. So how far is red from the finish line? How far is the red ball from the finish line? Well, we're going to take the position of the finish line minus where the red ball is, and that's going to be our answer. So where's the finish line? Oh my goodness, I already forgot. Is it 94 or 93? Sorry. 93. Sorry about that. 93.5 centimeters minus where the red ball is on your frame of reference. Okay, well that's only 2. Man, that's close. Only 2 centimeters behind. Very close. All right, I'm going to pause the video and I'm going to do the same calculation for the blue ball, and then we'll talk about it. Okay, so now I've done for the blue ball what we had done together with the red ball, which is where is the blue ball when the white ball crosses the finish line? So what I do, same thing, is I get a different equation, right? I get the position equation for blue ball, and then I plug in white ball's winning time, and this tells me that on our frame of reference, the blue ball was at a position of 76.1 centimeters. But that's not the answer, right? That's where the blue ball is according to our frame of reference. The question we want to answer is how far behind the finish line is the blue ball when the white ball crosses. I was just kind of thinking that that's not good English grammar, but basically, how far behind the finish line is the blue ball when, I'm just going to stick with that. How far behind the finish line is the blue ball when the white ball crosses? So in a mathy sense, we're going to take, well, this is the position of the finish line minus the position of the blue ball when white crosses is then that's the difference between them. So the finish line is 93.5 centimeters. The blue ball is at 76.1 centimeters. And the difference between those is 17.4 centimeters. So the blue ball definitely comes in third place in my race. And so it's a very, very close finish between white and red. And blue ball is, sorry, blue ball, but you're definitely in third place. All right, I'm going to pause the video and then we're going to watch it together. And hopefully it'll show up on this screencast. Okay, we're back and we're ready to test my prediction. I predict that the white ball will win. The blue ball will come in second place behind, and it will finish behind by 2 centimeters. And the blue ball, did I say the red ball? The red ball will come in behind in second place, just 2 centimeters behind the white ball. And the third ball will definitely come in third place, 17.4 centimeters from the finish line. Now you can barely see, because of the way my frame is set up here, you can barely see the blue ball. But there it is. All right, on your mark, get set, go. Well, check it out. Okay, let's see. So let's freeze the video right when the white ball, not there, the next one over. All right, here's the finish. The white ball has just crossed the finish line. Let's get out the meter stick. And I think we're pretty happy because, okay, I can't do it, but let's just see. That, I'm looking at the red ball right now. All right. It's like 1.5. If I back up one frame, I can, well, let's see. Anyway, about 1.5. I said 2 centimeters. That's pretty darn good. Let's see. If I claim that this is the winning position here, then it is 2 centimeters. So, but it's not sure. I mean, so it's a little bit less. It's like 1.5 to 1.75 centimeters. So that's pretty good. And the blue ball, I said was 17. And under this one, if I match this to 100 and I go, there's 10, it's 16 centimeters behind. So pretty good. Remember, physics, it's about predicting the future. And I was able, using physics, to predict something that hadn't yet happened. And I think I did it pretty well. There you go. You're going to do the same thing. When things turn out well in physics, you get a warm, fuzzy feeling. So I got a warm fuzzy from this.